Welcome to the Valve Studio. Welcome to also all the new subscribers to the channel. I'm in the middle of this journey I really haven't talked about before. We've talked about pieces of it, but it hasn't really congealed into something until I was talking to AJ over the weekend. And he said, how is that your speaker project going? I said, it's going okay. And he goes, that thing is like Tonehenge. I was like, oh, that's perfect. I'm on a journey to Tonehenge. So what I do here is I work on guitar amplifiers, primarily vacuum tube amplifiers, and exploring their nuances. And I started this journey, one of these journeys within this whole thing called the Valve Studio. When I read this book a couple years ago, this is Dave Hunter's Guitar Amp Handbook. And this is a really well-written book about guitar amplifiers. And there's a couple of sentences in here that started this journey probably 18 months ago. So I'm going to read this to you. This is from Mark Sampson of Star Guitars. And he's in the Meet the Maker section in the back where Dave interviews a bunch of amplifier designers. He says, it sounds like you're saying it really comes down to a lot of listening and a lot of testing of variables. And Mark replies, yeah, I have a test bench that I use, although it's packed away right now, where I can mount up to 6 output transformers with one big rotary switch, and then I listen to them back to back. Then there's another knob where I plug in 4 speaker cabinets, so I can listen to 6 different output transformers with 4 different speakers and listen to all the combinations. So I was like, oh, that's ingenious. What kind of speakers does he have on his test bench? So I wrote him, contacted him through the publisher of the company here, and he wrote back to me and he said, my 4 speakers are an old KLH 50s hi-fi speaker, a modern Tannoy bookshelf speaker, a vintage 30 open back cabinet, and a generic name 100 watt 10-inch speaker in an open back cabinet as well. First 2 are for audio, second 2 are for guitar. All right, so I need to have this array of speakers on this switch network. So I did work on the speaker selector here. There's a video about that. And when I had this bench made, this mighty fine steel bench here, I particularly made the top shelf 16 inches down from the ceiling in this room, primarily to house different cabinets and with different speakers, focusing on 12-inch drivers. So that's where we are. I have the prototype here for the speaker cabinets. I'll show you the CAD model I have for this. And I made this, I actually had to make, this is what is this stuff? It's like a 3/4 inch pine from Home Depot. And it uses finger joints up here to hold it together. And this is designed to fit up, it's going to be tipped upside down and mount to the shelf up above so that it reflects off the ceiling in here, much like you would if you were using it as a guitar amplifier. And also up along here, you can't see it, but I have a Sennheiser E609 microphone to mic all these speakers. So when we do, A, B, C, D, E comparisons, we can have proper placement, proper distance, that type of thing, and look at SPL levels, frequency response, tonal characteristics, those kind of things. And it's on one of those magnetic indicator mounts, so I can easily move it to the next speaker. So I've been working on this for a while, but it really came together when AJ said Tonehenge, and so I am on this journey, and it started 2 years ago, and now I'm on the section where I've crossed into making these speaker cabinets. Yes, I could go buy these on eBay, a 12-inch cabinet like this, that's pine, solid pine, would be, I don't know, maybe $120. I could buy 5 of them and I'd be done. But it turns out that, a lot of these people that know about amplifiers, Dave Hunter mentioned this in one of his books, is he said that, the vintage tone that people are looking for, one of the reasons why they go for these vintage guitar amplifiers is the fact that the construction techniques as well as the materials that Fender and Gibson and, you know, Valco and all that kind of stuff were using back then was really what they could find, and they were in mass market, so they were using inexpensive materials, and so they used really whatever they could get. And those cabinets now are about 60 years old, and so the glue joints are really kind of loose. So if you want to look at really if you're really on this tone binge, you got to take into account the cabinet, the materials, the construction of the cabinet, and particularly the choice of material for the baffle. That's the thing that holds the speaker onto the front, and its attachment points to the back cabinet, whether it's open back or closed back, whether it's damped inside. There's just a lot of variables in this, and I wanted a way to be able to easily make these, and then when I actually get down to doing some guitar amplifier designs, I want to be able to handle 8-inch, 10-inch. I have some 15-inch drivers up here, both a new one from Jensen as well as, you know, some vintage ones that I picked up over the years. So I need a way to make those, and I don't want to do I want to have control over the materials, the construction, the adhesive, all that parts of the design, and kind of use that as part of the exploration here. So last, I think it was December, Antique Electronics Supply, tubesandmore.com, had a 25% off sale on guitar amplifier speakers. So I bought 3 back then, and I have down here under my bench Celestion 12, a GH12H, which is a 30 watt 12-inch woofer. It also has a Jensen Jets 12-inch, which is a 70 watt speaker. And I bought these particularly because they're distinctly different from each other. I have an Eminence Patriot 12-inch Swamp Thing at 150 watts. What's in here now is a Weber Ferrell Max. It's probably about, it's called vintage on the back. It's probably about 50 watts or so. And then I have I have a collection of 8-inch woofers back here. So I want to be able to switch these out easily, try different materials, look at different techniques, match them up with like what Samson was doing here with output transformers. When I get into doing design work for output transformers, look at the pairing of those. And with the speaker selector here, as well as this rotary switch idea that Mark uses for his test bench, I'm going to be able to look at a lot of different combinations. And when you're doing design of guitar amplifiers, you do want to take particular care in the selection of the speaker matching to the output transformer, to the output tube, and the design of all the components and that kind of thing. All right, so let's see. Anyway, about 10 days ago, Openbuilds.com, I've been on their mailing list for a couple years now, kind of wanting a wood router for my garage. And I've been waiting for them to offer a big enough platform for me to cut these panels out all the way up to 15 or even 4/12s, which is quite a big cabinet. But I wanted to be able to do that because let's say my woodworking skills are to be desired. And I'm more interested in what's going on the electronic side than the actual craftsmanship of these cabinets. So I could talk a little bit about that. Well, I learned a lot on this one, and I learned that I don't want to do another one like this because it just takes a long time. So they had a sale, 20% off, and they're offering the new machine that I was looking for, which is a 1,000 by 1,000 millimeter machine that is lead screw driven on all the axes, and they're in some kind of joint operation with Ooze Nest in the UK, and they're now offering one of their machines called the WorkBee. So 20% off. I was like, wow, now is the time. So I ordered one of these and actually waited for the sale to hit so that I could get right on the front of the list. I ordered it. It came in last Friday, and now part of my journey is to take my design here and translate it into using the WorkBee. So I'm going to go ahead and cross over onto the computer here. I'm going to show you the design of the cabinet. I'm going to show you the WorkBee, and then I'll show you my build progress for my WorkBee that I'm going to put into the garage. Okay, here's the picture of the top shelf up there currently. Like I said, this distance from this shelf edge to the ceiling is about 16 3/4 inches. So a 16-inch cabinet will fit in here fine. And this is the Sennheiser E609 I was telling you about. It's on this articulated arm that is hooked up to one of these dial indicator magnetic mounts. And since this is a steel bench, it clips on there really easily. And with this arm, I can move this microphone around any kind of orientation and kind of get whatever distance I want up here, with the arm and this distance along here on the indicator shaft. So up there right now, I got a bunch of other older speakers, but I do have this. I found this over at Habitat Restore. It's a studio monitor. It's a JBL studio monitor. Unfortunately, there was only one of them, but it's okay because this is really a nice speaker for my audio testing here in the Valve Studio. All right, so we'll move on to the speaker portion of it. Let's go to the design. Okay, so this is over at onshape.com. If you look up 12-inch guitar speaker cabinet, this is what I've actually drawn up. It does have finger joints on all 4 joints. And I downloaded a model off of GrabCAD for a Celestion 12-inch speaker. And so, if we kind of come around here, it's open back design, but it can be closed back if I put an extra panel in here. I have a little speaker jack down here that I bought at Parts Express. And it has binding posts, and then I go ahead and mount the 1/4-inch jack in it. And these top holes up here are to when I flip it upside. Well, it's for a handle if you want to carry it around. Put a handle on it. But when I flip it around, I'll be able to screw this thing down to that bench top up there, so it won't fall off. And that way, it'll kind of be upside down like this. And then if you look at it from this angle, this is the ceiling right here. So it's going to equivalently be a floor. If you kind of look at it that way. Okay, so this thing, I needed to make it kind of small to fit up there, height-wise. But this particular design is completely parameterized. So I can, change the width, the height, the speaker diameter. There's a lot of stuff in here. And then if you come over here to the drawing section, Onshape is really good at creating these, taking your 3-dimensional model and making a 2D flats out of it, which are dimensioned. We'll show you this here. So I have all the dimensions here. And I have the cleats as well. So let's go back to where we were. This is the full assembly. If we push a section view on, come on, what's going on? Oh, there it is. Let's go to half the size here. And so you can see I have plenty of room inside of my enclosure. And if I want to use this small enclosure for a guitar amplifier, I'll easily be able to handle that. I can do like a classic champ type style where, this top part has a little notch and then the controller top mounted. There's not enough space up in the front to have a front panel. But there's plenty of space in here, and it's all held together with all these cleats are glued in, but the speaker baffle is using 5/8 inch, not 5/8, number 10 T-nuts. And so it's real easy to remove the speaker and replace it for, if you want to test out different speakers in the cabinets, you can easily replace these without having to tear it apart. And this is a 4 connection point design, where the baffle is only held on with these 4 screws, and there is also a provision to provide for spacing between the baffle and the actual rear of the enclosure, for if you want to put Tolex on here, as well as a speaker cloth. All right, so that's what I want to try to make. And so the first thing I had to end up doing was I had to make a finger joint jig for my my router table. So I had a piece of 20 by 40 extrusion, and in this I cut a notch out of here for when I slide. And then I bought one of these slides to go into the 3/4 inch slot, and on the back side I got like a pretty beefy connection between this and this slide. And I notched this out over at Rob's on his milling machine. And then to adjust the tongue and groove, so to speak, width, I have an inside angle corner that rides in this bottom slot. That's just a little bit narrower than a 1/4 inch slot. So I wouldn't want to go smaller than a 1/4 inch. And this is a test piece, and this thing throws out tons of sawdust. So if I'm using this particular method, I have to really be cognizant of dust management. So here's what a finger joint. This is my first finger joint I ever made. You can kind of see it's really kind of tight, and I was really excited about the kind of quality I was able to get out of that. All right, this is my setup. Like I said, this is the fence to hold the things on. And if you come in here, you can kind of see this inside corner joint right here. And most of this is just straight, extrusion corners and brackets and things. All right, here so I went ahead and did all 4 of these corners, and it was, my test piece was a piece of 3-inch wide piece of stock, and it went together really well. But when you get this many fingers at this size, I had to basically beat the crap out of this with a mallet to get the finger joints to fit together. And it was it's really quite stiff now. I did use I put glue on every one of these the grooves, and the slots and tongues, I guess you want to call it, or tabs. I think they call it tabs and slots or something. Okay, so it's really quite stiff, and then I ended up adding in all the cleats. The hardest part about this entire project was this front panel sits at a 7-degree angle off the base, and these cleats also have to be made at 7 degrees as well. And cutting them with that angle is easy. However, clamping them is really difficult. So I'm going to have to figure out a clever way to actually clamp these down at that 7-degree angle. Oh, here's the finished product. This is the front, and here's the back. Like I said, this one's got a Weber Ferromax in it. And here's that a binding post speaker enclosure. So this is one of those 5-way things where you can use bananas, you can use pins, you can use wire. These are threaded, and I ended up mounting a 1/4 inch jack in here as well. Okay, so we'll go over to, I showed you all 3 of those. All right, now down to the WorkBee. So here's the Oz Nest is the website in Great Britain that sells these kits, and this is, like I said, 1,000 by 1,000. And Openbuilds has a kind of a design team that's been working with Oz Nest to offer these kits in the United States. There's a complete set of documentation down here, and it talks about, there's different orientations on how you at your Z distance. You have 2 configurations that you can put the extrusion in the frame to have different Z distances. So if you're going to like mill aluminum, you want to be, your stock needs to be as close to the bit as possible. All right, so over at Openbuilds, this is a company in New Jersey. Like I said, they had a sale over the weekend. Right now, it looks like all their machine bundles are free shipping, which is good. Because my package for 1,000 by 1,000 was 55 pounds. Okay. So, I'm gonna get my dog to lay down. So, I got this one. I got they call it the 1010. It's 40 by 40, and the working area ends up being about 31 inches, 31 and a half by 30. And like I said, it's a screw drive everywhere. And if you go over to their forum, they have a complete build video that goes on for 2 hours and shows you what you need to be cognizant of. Basically shows you everything. And they sell everything that you need for this. Let me see. The last thing was, that the integrated stepper thing is called a IHSS 573620. Okay, so if I come down here, I bought this directly from JMC. I think it's here. Let's see if it's here. Yeah, so this is it here. It's a 2 Newton meter stepper motor, and it has an integrated driver up here. Like I said, it's a servo drive, so it actually will hold the step, and it actually controls all the acceleration parameters and the stepping, and you can run these things. It has its encoder is capable of doing up to 50,000 steps per rotation, so it's crazy accurate. It's really quite strong. I got these things, and then I realized after I got them that the couplers that are sold with the WorkBee from Openbuilds are to go from a 1/4 inch, which is 6.35 millimeters motor shaft, up to 8 millimeters for the lead screw, but these are 8 millimeter shafts. So I'm going to have to buy an 8 millimeter to 8 millimeter coupler for all my 4-axis. But these are great motors. I'm looking forward to using them. It dramatically simplifies the design because the motor drivers are actually on board and you just connect them up here. All right, so that's the motor. I forgot one thing. So this is the WorkBee. That's I brought it in Onshape. I just did a straight import. There's a collection of CAD files over at Openbuilds in a forum that are for everything kind of a symbol, and I'll go ahead and show you one more thing here. So this is for the 750 by 750 model. So basically the 1000 by 1000 just has 1000 millimeter extrusion here. But for what I need, it's great because this is just the X and Y is different, but the Z is all the same. So here's their clamp for your motor spindle, and I'm using a Makita, which is going to require a little bit of a shim here, but that's fine. Well, I was telling you about the orientation of these last 3 members here to hold your surface up. In this configuration, your work surface is a lot higher up, closer to this pivot point right here on the Z, and so it's going to be more rigid and it'll be more accurate. But I want to have some distance there so I can actually carve out fairly large depth in Z. So you basically flip these things and then you reorient this piece here, and you're gonna actually gain 40 millimeters in Z. It's really convenient to have this model because, let's say, back over here, I only have the mechanical kit. So like this is a drag chain, and this thing right here is, this guy is this connects the drag chain up. This is like a little bracket. So you can click on this and just say export, and I can export this right to STL. And so I can just 3D print this part and hook my drag chain up right to my WorkBee. Their particular design has all the electronics mounted on this axis here, and I'm going to do something a little bit different, which we'll talk about in future videos. Let's go out to the workshop. All right, I'm out of my workshop, and my workbench is behind me, and then I have a little staging area here. And this is where I'm doing the build, or at least, you know, getting the parts organized. I got all the parts on Friday, and yesterday I started. It took me almost 2 hours to get everything unpacked. Openbuilds did a fine job of packing all this up. There's no damage to anything in here, including the lead screws. So I'm very happy about that. I started the build after watching Matthew's 2-hour build video. I watched it in its entirety the first time when it came out. And then I watched portions of it again before I actually got started doing assembly. I also downloaded the instruction manual from Ooznets, and I have that as well on a tablet somewhere. So I started building the gantries. So I have both Ys done, and I also have the X portion completed. And I built this last night when I was watching a movie. And I haven't built any of these. These are V-beams. These C-beams. I haven't built anything with these before. These things went together flawlessly. Very tight, even without even doing the loading of using my cams yet. I have very little play in the beam moving amongst the wheels. And these are super beefy. They're really well made. And it's a classy that Openbeams went ahead and etched all the anodized aluminum as well. This can be quite a machine when I get it done. So I did make one change to the build. I'll tell you a little bit about that. So I did some research before I started building into dust collection for this router, and one common way of doing it is to connect it to the router, so it actually moves up and down with Z, and that's fairly easy to do. You just kind of basically slap it on the end of your router with a circular fixturing. The other is to not fix it to Z, only fix it to X and Y, so it is at the same level, and your router moves in and out while the dust collection actually stays, at the same elevation while your router goes up and down in Z. In order to do that, I needed a way to attach my dust boot to this platform here. So if you look at the design, the Z plate connected to the X plate here is using 20 millimeter low profile M5s and a lock nut. So I went ahead and bought some 30 millimeter low profile M5 screws, and I'm using these instead. So when everything is put together, let's see if I can come over there and I'll show you how these things are in there. This is something you pretty much need to in order to make this change. It's quite a bit of disassembling of your router to do this. So it's a little. Let me just show you what I ended up doing. Okay, so this is the Z. This is the Z movement. So your router is going to be on this piece of extrusion. And then this is going to go back and forth in X. Okay, and then forward and back in Y. And so I needed to hook to this frame here, not this one. So these are the M30 screws that I put in, and I have an extra 10 millimeters of length here. So everything is fixtured up, and these plates are really well attached with this M5 lock nut here, or nylon nut. But I have this extra thread coming out, and you can see the clearance here on the side of my my Z-axis, that right here. So my plan is to have two legs come off of this and go down. Let me get back here a little bit. Two legs come off of these four nuts here and go down, and then hold the dust boot down here. And then when Z goes up and down, the dust boot stays at the same elevation. All right, so about 2 in the morning, I get to the part where I'm actually making this thing, and I realize that my kit is shy 2 6mm aluminum standoffs. It says on my my build here, the checklist goes and says I should have got 27 of these, but I only got 26. No, I got 25. And so I spent about an hour looking through all the garbage from the shipping and packing material. Couldn't find them. They're just not. They're not here. So I'm kind of on a hold in my build until I figure out a solution to that. So I figured, how hard is it to make that? The only really critical dimension is the 6mm, because it's going to hold the plate out. But then as I was building this, I realized just the complexity of how the Z plate connects to this X plate here. To being able to add those in or fix them later is really, there's a lot of building going on there. So I took apart one of my Y plates, and I pulled these are the ones I built first. I pulled the spacer out here and left these loose here, because you can get access to this a lot easier than you can to the ZY combination. I took those out, and so I was able to complete this and get it together. A really good registration, and it's a beefy part. So I was like, well, how hard would it be to make this? I'll just need a 6mm spacer, and I need it to, butt up against that precision shim so that it ultimately comes in good contact with the wheel bearing. All right, well, I have 3 friends in town that have lathes. 2 of them actually took the weekend off, which is good for them. And one of them was actually working on his truck. So I went over and I said, hey, I have this piece of aluminum here. Can you just cut me a couple of these shims? He's like, oh yeah, no problem. Well, he struggled with it for about an hour. Let me see where I got that thing. And this is a piece of round bar stock that I got at Home Depot. And he says, what is this stuff? And I'm like, I don't know. It's just whatever they had in the bin. Well, you never know. You never know what you're going to get from Home Depot. So I don't know what this is. He says it's definitely not 6061. Because when he went to try to cut it off and use the cutoff tool, this cutoff tool, I don't know if it was dull. I don't know what the situation was, but he wasn't able to cut it off cleanly, and he left a little bit of a ring there. Like when he was running through the part, the aluminum would get really hot, and then it would kind of melt onto the tooling. And so he goes, this is all crap. So he spent about an hour. He made me one, but he measured it to be 6, but it's really like 6.9, which is bad news. So he's going to make this for me again tomorrow out of 6061 that he has. So I'm kind of on hold until that happens. I know I could build this frame now, but I'm just going to wait. My motors are coming in on Wednesday, and so I did find the drag chain. I have to 3D print. This is just a mechanical kit, so I have no electrical components for this. I do have all the limit switches for my WorkBee. I have the drag chain, but I don't have the mounting brackets. But on the 3D model that comes that I got from Mark over at Openbuilds, it does have a complete assembly of all the step files, and so I can easily 3D print those pieces by just exporting STL right out of Onshape. So I have to do that. What else? Oh, so when I mount this thing into my workbench, you'll see behind me. This workbench. Let me just talk a little bit about this because we'll be talking a little bit more about this in this series. I built this workbench, I don't know, 2 years ago, maybe 3 years ago, and with goals to be able. One of the main goals was it needed to be high enough because I'm a tall guy, and also I wanted to be able to completely work on 4x8 sheets of whatever. So this is actually about it's 5x9, so I can put a complete 4x8 sheet on there, and it has a feature built into it that all my power tools are not permanently mounted to the top. They're also not on wheels around the shop here, but they're embedded into the top of this workbench. And if I need to use like my chop saw, I can pull a chunk off of I can pull a surface off of there, and I have the chop saw on a hinge that I can just pull up and secure it, and now it'll be flat. And I have in my workbench now, I have a belt sander, a drill press, and my chop saw. And when I partitioned out the table, I left nearly half of it on this end specifically for a CNC machine when I actually got it. And so I did a lot of measurements with the WorkBee 1000 by 1000. It's just going to fit into this, which is great. So I know how I'm going to do that. I'll just basically kind of show you. So when I want to get down to using my WorkBee, it will actually reside down under here. And then I pull this top off, okay? And then I'll have a way to elevate this up to the right elevation. Let me get down here. Elevate it up to the right elevation, plug it in. It's going to hook into my vac system here in the wood shop. And I'll be able to use it here for projects, like this speaker cabinet build. And then when it's not in use, I can move it back down, put the top back on, and I have my 5x9 workbench. This workbench is also on wheels, so I can wheel it around and change the orientation here in the workshop. The chop saw has the ability to have one of the original wings that come out from the chop saw for doing long extensions, as well as a fine adjustment for the length of the chop, and it hooks onto that end as well. All right, so that's it from here. Let's go back into my lab. So I think along this journey, there's some additional steps in the construction of the WorkBee. One of them is the motor choice. The other one's electronics. There's going to be videos about this, but I'll just give you a little introduction here. So I'm using this thing here for my coil winder, and this is an integrated step servo. It's a NEMA 17, but the WorkBee wants 23s. So I ordered the NEMA 23 version of this, which is a 2 Newton meter one. It's got integrated electronics up here, and it's a stepper servo, so it will not skip steps. Okay. It will do what it has to get to the right step that you've actually instructed it. So with these, you can power these. I'm going to power these directly right off of 36 volts, and I can run these right off of a Gerbil board or so without having a motor driver or anything, and just do a lot of low signaling out along my my drag chains. The other thing I've been looking at is options for, do I want a Gerbil, and then do I want to put a Raspberry Pi with a touch screen on there? It's just like there's a lot of options at this point. Should I use the laptop, run UGS, or should I run Chili Pepper? So that requires that I run Node somewhere. Anyway, I've been looking at other options beyond just using Arduino for CNC control. And I'm really familiar with how Gerbil runs both externally as well as internally. And so we'll talk a little bit about that. But currently I'm leaning towards this thing here. This is called a Cypress PSOC 5. This is a very interesting board. We'll have a video about that in the future. All right. Well, that's where my build progress is today. I know it's been a long video, but thanks for watching, and stay tuned for future updates on my build progress for my WorkBee. This is the Valve Studio.